Okay, we need to return to the basics of the operator overloading. Self A is equals to A, okay? And def at can be rewritten as the self S, and it is instance as sample. It's a class variable, and so we can return to the sample new object self A plus SS. If is instance, is it the normal integer value, and we should return to the sample self A plus S, okay? And that str self can be returned into the F number self A. Okay, so A is 10, S is the sample 10, okay? And so the result can be built with the S plus A. And so we can print the results. What's the output of this code? What is the output of this code? Yes, to win. Right? So again, A is equal to the 10, and so result A plus S. Print result. What's the output of the second code? What is the output of second code? Anyone? In the second case, if you run this code and say unsupported operand type as for plus integer and the sample. Yes, error, but why? The Python interpreter sees that code as the as at A, but Python interpreter sees that code as just like this one, and so this code does not exist because the A is integer. Integer does not have the add operator overloading with the sample class S. Okay, this is the error. Just remember that. Okay, how we can avoid this condition? How we can overcome this problem in here? And so we can create another sample class just like this one, the init self A, and self A is equal to the A, okay? And then F self S, and so the print, this is the if is instance S sample, and so we return sample self A plus SS, and also if is instance S int, and we should return the sample self A plus S, okay? This is the case, but we have also R at function. This is the print R at return sample self A plus A, okay? And also the str self and print str, we should return to the str self. Okay, so this are add, and add has the different property in here. But why? See, a is equals to the 10 and s is sample 10. Results can be built with what? S plus a. Okay, and so we can print the result in here. In this case, only at str and 20 are seen in the terminal because s is called just like this one, s at a. But what about this one? A plus s right now. If this is the case, just see our at is called right now. See what is the difference between these two codes? You need to understand that the add function is utilized to what? To obtain this combination. This is the normal, this is the reverse add operation. Okay? You understand right now? What's the purpose of the add function? Yara? So, we have one more specialized function in here also. Plus sample, we have the call function value, self x and y. Okay? And so we can print to the what? Call, comma, format x and y. This call is the what? The operator over calling, or the function calling operator in here. And so we should return to the what? The x plus y. Okay? So what happened if I define the sample class just like this one, and also result can be built with what? 20 and 10. Okay? And so what happened if I run this code? This as possessed what? The overloading mechanism about what? These parameters. Okay? And so if I call, as a call, 10 and 20 are seen in this page. Also, we can write the s call with parameters of what? The 10 and 20. These are identical. See? And so what happens if I print the result in here? What is the result right now? What is the result? What is the result? Yes, 30. Thank you, Yara. See? This is the function calling operator. And so we can overload this operator by using what? The underscore underscore call underscore underscore function. Okay? And so we can generalize this solution for the what? For multiple parameters. Just remember that how we can build the multiple parameters call or this function operator, and just remember that we can build the what? The double star or star arguments in the default arguments, right? And so this class sample can be assigned with what? The def in it, right? And so self a and also self a is equals to a. So we can write the call just like this one, self and args and double star cube args. Okay, and so we can print the what? A is equals to parameters of the format self a, right? So what happened if I build the sample 100 in here? What happened? What's the output of the terminal? What is the output of terminal? If I run this code, there is no output in the terminal because this calls to init function, not call. But if I choose the 10, 20, and 30, what's the output of this code right now? Now, just see that if I run this code, see, the init function takes no arguments in here. We cannot drive these parameters right now, Donia. We can be put this function in here. Do you understand, Donia? We cannot put this 100 in here. It's because it's the default constructor. If we want to apply or give some arguments to the constructor, we need to write the init function. Okay? Donia? Because the default constructor is given in here. See, as 10 and 20 print this function. This sample is a class generation. See? If you remove this part and so, see? 10, 20, and 30. The class attribute A does not possess in this case. Donia. We don't have any A function in here. Just see that this format can be built with what the 10. And so, see? A is equals to 10 is given here. So if I write this code and so simple init function possessed one required positional arguments. Okay, and so the 100 should be given here. See, A is equals to the 100, but not the 10, 20, and 30. And so how we can print these functions? The print args is equals to the what, these parameters, and so the format args, right? And so if I run this code, and so arguments is seen also 10, 20, and 30 values. Okay. What about this one? X is equals to the what? 40, and y is equals to what? 50. See? If I run this code, the same person is given here. But if I print the key args is equals to the what? Format equals. Okay? And so in this case, see, right now we can reach or we can define any variables by using the call function, and so we can assign the arguments and the cubargs arguments into what? Into the arg class. Okay. Do you get it, guys? Okay, so that's it for this week, because it's too much to learn about the operator overloading. These codes are hard, but you need to study about these operator overloadings. Okay, this is the tough one for the Python learner. Okay.